The final method that we're going to take a look at is the analytical model. Now, you can think of the analytical model as a tool that will allow us to validate our interpretation. So validating the interpretation is obviously important. Everything that we've done up until now, looking at these different type curve matches, we may have slightly different answers or significantly different answers. There's no way to know really what is the best possible answer. If you're working at an operating company and the management wants to see what the interpretation is, what the reserves are, they're usually looking for one answer, one best possible answer. So we can obtain that by using this analytical model. And the way the analytical model works is it doesn't produce results such as permeability and skin. What it does is it uses the results from the other methods. For example, I've got a list of all the permeabilities I've calculated here, and I can populate the model with those numbers. And the idea is I produce that model, or produce a history match with that model to try and match the data. So let's do that. We'll populate our properties, and we can choose any one of the analyses that we've worked on. For example, the Blasingame type curve analysis. We've populated all the inputs in the model with the results from Blasingame, and now we're viewing a history match. And the history match is a way of validating the interpretation. This is a pressure history match, and we can also show a rate history match superimposed as well. If both of these data sets match well, then we know we've done a good job. And if they don't, then we know we need to maybe go back and do some more work to determine how to fix it. In this particular case, things are pretty close, but I can maybe improve the match a little bit over here. I can do that by using the automatic parameter estimation feature. So what I'm doing right now is I'm flagging the original gas in place and some of the transient parameters for automatic parameter estimation. And now the program will go through a routine where it tries to minimize the error. When I'm happy with the result, I can click this off, and that's my final interpretation. So the results from here sort of represent my best possible model. Just very quickly, let me show you some of the other features. This is a schematic of the model that we're using. We can change the position of the well dynamically, so you can see the history matches changing as I do that. We can change the size, the dimensions of the reservoir. It's very easy to dynamically set up the model and immediately see feedback based on the history match. So let's get that thing back into place where it was before. Bring these components back into play. And do our automatic parameter estimation one more time. And once again, we're ready to go. Okay, so as a final step, we'll do a production forecast. The analytical model, as well as all the type curve methods, allow us to do production forecasting. And we could do that for each of these methods, but we'll just do it for the analytical model because that's our best answer. So what I'm going to do is enter in a duration of 30 years and generate a production forecast for that. And I'm going to put in an abandonment rate here just to ensure that the forecast is being truncated at an appropriate location. If rather than flowing the well at a constant pressure, maybe I'd like to decline. We can see that historically the pressures are declining through time. So the forecast capability of RTA allows me to change constraints through time. So instead of just running at a flat pressure, I'm actually going to run a forecast for, say, 12 months where we have a pressure that declines through time from this 153 psi maybe down to 50 psi. And we can take a look at what that looks like. That is maybe a little bit too steep of a decline, so I'll add another 2 months and make it a 14-month forecast. And now we have something that's a little more reasonable. It's an extrapolation of the historical data. And then I'll add another row to this and make the second period a 30-year forecast at a constant pressure of 50 psi. And that's probably a better forecast. Okay, so that's our production forecast. We have an EUR of about 2 BCF with an in-place gas in place of 2.3 BCF.